Thank you, David, and congratulations on this spectacular room. This is, makes a Wired editor feel proud to see the brand show off like this. As you say, I am fascinated by the real world these days. As children of the web age, what we've seen is this extraordinary moment and sort of new ways of working together. And what we now see with the things, some of the 3D printing stuff you've seen up here and you'll see more of later, is a new suite of tools that could be even bigger than the internet. I'm going to go through my presentation, hopefully show you a little demo involving a drone. I'm slightly terrified by the fact that our four-bladed flying lawnmower is right next to the Stradivarius violin. Hopefully this won't end poorly. But let me dive right in. These are the only words I hope you'll see on the screen, but this is the thesis of my book and all my work of the past few years, is that we have spent 20 years pretty much rethinking what it means to collaborate, what it means to have a company, what it means to innovate. The web has allowed us to break outside of all the traditional institutional boundaries that defined the 20th century and before. That's fantastic, but it's in the world of bits. We live in the world of atoms. We live in the world of real stuff. And we have the opportunity now to take those experiments, those lessons learned on the web, and take them into the real world and move the needle in a way we never have before. You know, but what we have structurally is this. We have a new set of tools, the 3D printers, the CNC machines, the laser cutters, all this digital fabrication stuff you're starting to hear about. The key word on all of these is desktop. When you add the word desktop in front of any industrial tool, what you change is not just the size and cost, you change who uses it. And the fact that it gets into the desks of regular people changes everything. It creates a distributed manufacturing model, and in a sense akin to the origins of the Industrial Revolution, which was about cottage industries. At the desktop loom, you know, empowered a generation, or perhaps an era, of people to become entrepreneurs. We're doing the same thing with fabrication tools. And then meanwhile, we have these new sort of social models that we've established on the web, open source, crowdfunding, peer production, co-creation, all those things that have worked so terrifically in things like open source software and Wikipedia and artistic collaboration. We now have the capacity to put them together with these new fabrication tools and create the kind of stuff that the industrial age did not create. The industrial age was fantastic for mass-produced, the one-size-fits-all, you know, the sort of stuff that fits the economic model of big box retailers. But the world needs more than that. The world needs not just the mass, but also the niche. We didn't have a manufacturing model to address that, to do that before. Now we do. I think in the same way that the web created the long tail, an explosion of diversity and cultural richness that we all enjoy today, these new tools can create a long tail of stuff, a long tail of things. We can see as much creativity in the physical world as we have seen in the digital. The original Industrial Revolution we think of as being about the machines. What it did is we used steam power and then electricity and mass production techniques to create things with incredible efficiency, but they had one cost, which is that the people had to go to the machines. And the modern city was created as people flocked to work on the machines and serve the machines. And that retained the industrial model for many years, a century or more. But that is a centralized approach. If you own the machines, this, to use the Marxist phrase, if you own the means of production, you have power. Well, most people didn't own the means of production. The point is that today they will. If you look at the first Industrial Revolution as being a mechanical one that was centralized, the second Industrial Revolution is probably the information age. And this one was not just the creation of computers, but the democratization of them. It was when we took the means of production and handed them to everybody. Now, it started with desktop things, the desktop computer, and here's the first desktop laser printer, the Apple Laser Writer, which cost $6,000 in the mid-'80s. We gave people printing plants on their desktop. We gave them software that allowed them to do typography. Then we allowed them, so that was great. They could make one. They could make prototypes. They could make samples. But we didn't initially give them the means to make many. We didn't give them the means to distribute. So there was still a kind of monopolistic control by big media of true mass communications. Then we invented the web and these publishing tools on the web like the blog, and then suddenly we had it all. We could democratize production, and we had democratized distribution, and that was the end of the 20th century media monopoly. We created the richness of the webs today. That and bits. We're now seeing exactly the same analogy happening in atoms. Instead of the laser printer, we have the 3D printer. That's my MakerBot. I now have several of these MakerBots. That's a very early one. These 3D printers cost less than $1,000 and can be made by children. But there's laser cutters, CNC machines, hand-pressed injection molding machines. These desktop tools are now becoming within the reach of, they're all under $1,000, and they're within the reach of amateurs. These are the things that were purely industrial, factory sort of tools just a decade or two ago, are now the sort of thing that you will ultimately be able to buy in a hardware store. But that's the democratizing the tools creation. That's how to make one or two. How do you make many? Well, simultaneously, we found that the world's factories have opened up to the individual. That's a website called Alibaba, but there's many others like it. And what it allows you to do is to upload your design and let factories bid on making them for you. And they'll take any units. They'll make 10, 100, 10,000, a million. It's just a different price. This has been driven by a real change, especially in China, where the combination of things like a web generation coming of age into management and a quest to decommoditize, to get out of the sort of the race to the bottom on pricing, allowed them to, or sort of encouraged them to seek out custom orders, bespoke small batch orders. And because these same file formats print locally on your 3D printer and print globally, driving the industrial machinery of the biggest factories in China, you can just upload your CAD file to a Chinese factory, and they'll make it for you. And a week later, it shows up on your desktop. And they take credit cards, and they take PayPal, and they don't care who you are. The world's manufacturing system, the global supply chains, are now impedance matched to the individual. In the same way that the web doesn't care whether you're the New York Times or a blogger, it's impedance matched to the individual. It doesn't care. It's scale agnostic. It has a place for everybody. That wasn't true for manufacturing. That wasn't true for the global supply chains until just now. Now, anybody can make anything. And the question is, what are we going to make? This is my grandfather, Fred Hauser, Swiss immigrant who came to California in the 1930s. He was an engineer and worked in the film industry. In those days, the film industry was a very mechanical business. It was a lot of tape drives and audio loops and things like that. But he was a tinkerer as well, and this was him working on his drafting table. And this is what he invented. He invented the automatic sprinkler system. And so my family's very modest fortune came from this. By the way, the automatic sprinkler system is exactly what a Swiss engineer would invent when they came to California. It's basically a sprinkler system with a clockwork on it. And he got the patent on it, and there it is. And this is where I grew up with this as my inspiration. I would spend my summers with him as a child. He taught me how to do mechanical drawing. And then later on, there's me at 12 learning how to use a metal lathe, which is a magical device. It's like sculpture in metal. You start with a block of metal, and you cut away the things that aren't the part you want. And this was I grew up believing that regular people could make amazing things. But my grandfather, although an inventor, was never an entrepreneur. He wasn't an entrepreneur because he could make the ones. In that combination, he democratized the tools of prototyping. He's gotten that. He was able to prototype, but he couldn't distribute. He couldn't manufacture. He didn't have a factory. And so he had to license his patent to somebody else, and they took it, and they did a perfectly good job with it, but he lost control. And so he was never an entrepreneur. He couldn't start his own business. And so I wanted to be an entrepreneur, so I didn't really see the point in following his path. I didn't want to just invent things and then hand them off to others to produce. There's a movie called Flash of Genius about the invention of the intermittent windshield wiper. And this is a scene from the movie. And this is it's from the same period as my grandfather was doing his thing. But this is a guy who made the opposite decision. He decided rather than just be an inventor and to patent and license, that he wanted to be an entrepreneur as well. And what happens is that he mortgages his house to build a factory. And a factory in those days was massive. Warehouses full of trucks and rollers and assembly lines and things like that. And it takes years and years and years, and he mortgages the house again. And before he's even finished, 1964, he turns the corner on a rainy day, leaving his still unfinished factory, and he sees the new 1964 Mustangs turning the corner to be unveiled in Detroit, and their windshield wipers all pause. And he realizes his idea has been stolen, he's ruined, he goes crazy, and the movie then spirals entertainingly into his descent into madness. But that's what happens if you dare to be an entrepreneur in the physical world back then. That's what's changed. It was expensive to produce. It was expensive to manufacture. It was hard. You had to build a factory. Today, you don't have to build a factory anymore. This is an example. This is a tech shop, one of the exploding number of hacker spaces or maker spaces around the world. And what you see here is entrepreneurs making physical stuff. The guy in the front is making a controller for a smart grid system. He actually has stickers. You can't see them. He has stickers in front of them that say ABB. And then when he's done with it, he just puts the sticker ABB on it, and then ABB, the huge Swedish engineering company, distributes it. And when you buy them from ABB, you assume they're made by a huge Swedish factory, but they're not. They're made by small entrepreneurs in tech shop in San Mateo, California. And there are many others around the world. The guy behind him is making a synthetic diamond deposition chamber, and in the back they've got a lunar lander, as one does. The point is, all of these guys, what a tech shop is all those tools that we've been talking about available to anybody, just like a gym. So when you think what a gym is basically more expensive workout gear than you can afford or want in your home. And instead what you do is you go in on a membership model, you go in and you sort of borrow these expensive tools, and you have coaches or trainers to help you use them, and you work around other people who are doing the same thing, and you get this sort of virtuous cycle. Same deal, but these are for digital fabrication tools. It's a membership model, $100 a month, and all those 3D printers and CNC machines and laser cutters and water cutters and CNC quilters. The one in San Francisco has all sorts of the fabric computer-controlled fabric manipulation tools and people to show you how to use it. And it's the exact same model. Rather than belong to a gym to become stronger or fitter, you belong to a tech shop to realize your ideas. And once you've realized it once, because these ideas are instantiated in digital files, they speak the same language as the biggest factories in the world. You upload them to wherever, and you can make them in any number of units you want. You can go from inventor to entrepreneur with a push of a button. These are just some of the map of just the latest maker spaces around the world. There are thousands of them today. There'll be one near you soon if there isn't already. It isn't an industrial revolution if it doesn't extend to cars. So here's the world's first open source car. It is the Local Motors Rally Fighter. It was designed by a community. Now it turns out that we've always had kit cars of various sorts, but they tend to be derivative designs. They tend to be models of famous cars like MGs, Porsches, and things like that. So the problem was not one of sort of, can you make a car? Because you can. The problem was, can you make an original car that looks beautiful? And the answer is, with the community, you can. So what Local Motors did they asked their communities, they said, make a car that's inspired by that P-51 Mustang, that World War II fighter in the background. But no intellectual property problems there. That's a plane. This is a car. And this is what the community ended up with. And this is the guy who did it, Sung-Ho Kim. He was a teenage student at the Art Center, Pasadena. And that was his design. And he won the competition. And others then chimed in and designed other parts of the car, the rear view mirrors and the little fender over the wheel. And there was something for everybody. And today, they're made in a factory like this, but not made by the company, but made by the buyers. What happens is the buyers then come to this factory, this build center, and over 2 long weekends, they put the car together with no skills required. And the reason they do that is threefold. First, the joy of having a hand in the making of something. It's something people just dream of. You can bring one of your children and do it with them. Secondly, the fact that it is at least 51% assembled by the consumer undoes all of the product, all the regulatory and product liability issues. It doesn't have to be crash tested. It doesn't have to go through a huge approval process. The liability issues are vastly reduced because the customer is an informed customer. They help build it themselves. And we see the same exemptions for things like home-built aircraft. There's a whole suite of loopholes in traditional barriers to industrial entry for things that are created in part by the consumer. So the notion of taking a consumer from an active to a passive role changes a lot of the barriers to creating new companies. The third thing that changes when you build your own is that when it needs to be fixed or you want to make it better, you're fully empowered to do so. You take the toolbox home with you. You know how to fix this. You don't send it back for repairs. It doesn't get recalled because there's a change. You can fix it yourself, and you can make it better. And if you do make it better and invent some way to make it better, you can then share that with all the other owners because we have an open, common platform for innovation called a car. That's one end of the extreme. The second is something as simple as toys. For Christmas, every year actually, but especially for the last 2, my children my boys who are really into Lego, and also into World War II in particular, have asked for more World War II Lego. Now, Lego company doesn't do World War II. They don't do any 20th century weapons at all. Family-owned company. But there is nevertheless a market demand for this. So what we've seen is the Lego community overall has taken matters into their own hand. And this guy here, Will Chapman, who also had boys, he has a CNC machine, and he has this thing here, a miraculous hand-press injection molder. And he just designs these weapons himself, CNCs them on aluminum to make a mold, puts them in the hand-press injection molding machine, and makes a few. And if people like them, he sends them out to a shop to make more. And you now have, let me go back. And you now have a really quite large industry of people making Lego accessories that Lego doesn't want to make. How does Lego feel about this? They love it. They love it. And the reason they love it is this. The biggest problem Lego has is that they lose their customers at 12. It's 9 to 12, but basically, somewhere in that range, the boys start growing up. And they want things that Lego doesn't want to make. Not only because it sort of doesn't fit their family image, but because the markets are smaller and more niche, and they only operate at the scale of mass. So there's a long tail of Lego demand, but Lego is a blockbuster company. So what these fans, these empowered fans, can do is keep people in the Lego world longer by selling them things that Lego doesn't want to make, but these people want in smaller batches. These are the 10,000s, not the 10 millions. And what's great about it is that it doesn't expose Lego to any of the liability or the intellectual property issues. And if these kids stay in Lego for another 5 or 6 years, then they graduate to Lego Mindstorm's robotics, and then they become adult fans of Lego. Then they start evangelizing to their own children, and you get them for life. And so what this ecosystem of makers around Lego does is extend the Lego market in the demographics and range of products in ways the company can't, but ultimately benefits the company. It's a win-win. So this is what I do. In a kind of failed effort of being a good dad, I thought I would interest my children in Lego, and more to the point, robotics and airplanes. And so one weekend I came home with a Lego Mindstorms kit and an airplane. The Lego Mindstorms kit builds robots. Children, unfortunately, have been completely ruined on robots. We built it, and it's a tribot. And it's a little sort of 3-wheeled thing that bounces into walls and bounces off. Now, when kids hear robots, they expect Transformers. They want lasers. They want them 3 stories high. the kids could not believe that that was even called a robot, this little toy. So that sucked. And then they said, okay, well, the next day we're going to fly a plane, a radio-controlled plane. And I went out, and because I suck at flying planes, I went straight into a tree, and that sucked. And so my children, my big weekend of science and technology is gone bust. The kids, once again, reaffirming that that outings with dad are bound to end in failure. And I went for a run because I was so frustrated, and I thought, actually the Lego kit also comes with all these sensors. Gyroscopes, accelerometers, compass sensors, Bluetooth connections that could go to a Jeep. You could build an autopilot out of Lego. And so that's what I did. I said, kids, one last thing. Let's build an autopilot. Because let's face it, a flying plane is a cooler robot than this little tribot. And the Lego has got to be able to fly this plane better than I can. So it worked. It's now in the Lego Museum in Billund, the first Lego UAV. And they instantly lost interest at that point, and I went right down the rabbit hole and decided to do drones. So this is what we do, and I'm going to, at this point, call up my friends. And while I'm showing some pictures, we're going to show you a little demo of what regular people can do with powerful tools. We start with open source tools like this, where we draw schematics. We then lay them out in circuit boards. And then regular people, we're not engineers, regular people can make extremely powerful circuit boards. And this is an autopilot, an open source autopilot created by a community online, including children, amateurs of all sorts, largely competing with the largest aerospace companies in the world. Now, okay, let's switch at this point to the other screen. And this is, so what we're going to try to demo at this point is, once we get this started, is this is a ground station. So what this aircraft is it's a quadcopter, it's a multicopter. It's intrinsically unstable. It can't be flown by a human. It can only be flown by a computer because it's your reaction time is not fast enough. What this one's going to do, if we can, we're in a room full of wireless devices, which makes these demos always treacherous. What this particular one can do is it can be completely autonomous. You give it waypoints, you give it mission commands, and then it just takes off on its own, exercises its mission, and lands on its own. Now, we're not going to do that here, although after the conference we may do it outside if you want to join us. But I just want to show you what is possible here. Are you all prepared to catch it if need be? So what you're seeing there is basically an autopilot is controlling the stability of this entirely. Martin is just telling it, basically pointing it where to go, but all the gyros, accelerometers, compass, and everything else there is controlling the motors. And it's got GPS as well. Thank you. Yeah, that's as much as we're willing to do in here, but we'll take it outside. And it's got GPS, it knows where it is, it knows where to go. It's a completely autonomous robot. And what's amazing about this is that this was, again, created by a community. They do planes, boats, cars, etc. Everything else. This is largely the cutting edge of aerial robotics, and it was made using the same kind of open innovation process that created Wikipedia. This is co-creation at work, and the reason we can do it is that we have the tools available to us. Regular people can design sophisticated electronics because you just download tools, upload files to production houses. Now we're ramping up and we have our own factory, but at the beginning we didn't need it and we didn't have it, and we were able to get into this business simply by using the web's innovation model. Can I switch back to my slides? Thank you. So this is what we make. That's that baby. And these are, again, what it looks like. This is a kind of, you get the real-time video and eye in the sky sort of stuff, fully autonomous aerial robotics. So this is the point, just to conclude. Making is manufacturing. My grandfather was a maker, but he wasn't a manufacturer. Today, you can do both. The act of taking your idea and turning it into a digital file on your screen and then printing it on your 3D printer, printing it on a CNC machine. The act of being able to prototype something is identical to the act of going into production. It's simply go to in your word processor menu. Right now where it says print. You ask how many you want. Well, so here's an example. In your word processor menu, you can pick print and it says how many. Imagine if that word processor, or the CAD equivalent of it, says make, and then how many. And you could put in 1, or you could put in 10,000. There's a number of services right now that are offering this. Shapeways is one. Pinocchio is another. Materialize is a European company, and they've just introduced a plugin to SketchUp. You just pick make. You design something in SketchUp, you pick make, and then this wizard walks you through the right materials, the right methods, checks your files, tells you how to lower the cost of the ultimate 3D printed object. We can now decide, it's simply a choice. Do you want to print locally, or do you want to print globally? Printing locally is prototyping, what hobbyists have always done. Printing globally is manufacturing, what hobbyists have never been able to do before. Imagine a world where it's simply a matter of which drop-down menu do you want to pick. Do you want to be an entrepreneur, or do you just want to be an inventor? It's up to you. The world's supply chains have become scale agnostic. So I'm just going to end on this note. We have two worlds. This simple change in the technology of production has disrupted the notion of what it is to be a company. On the left is Ronald Coase, the famous Chicago economist who came up with the theory of the firm. And he said, companies exist to minimize transaction costs. That means we work together under the same roof with job descriptions and common purpose because we need to get things done. And you need to know who does accounts receivable and who does accounts payable. You turn to the person in the cubicle left, turn to the cubicle at the right, and they do something else. You know who gets things done. The guy on the right, Bill Joy, one of the co-founders of Sun Microsystems, said, that may be so, but whoever you are, the smartest people in the world don't work for you. And that was just the way it had to be. It's like, you know what? I'll settle for the people in the cubicle next to me rather than the smartest people in the world. Because, I can't find the smartest people in the world. They're not available right now for any given job. And by the way, maybe it's different people for every single function. Every different job would be different people. What we've created is the opportunity to move outside the firm, go outside of the single roof and create a community. Make Magazine is the Bible of the maker movement. And that's my co-founder of 3D Robotics, Jordi Munoz, on the cover there. I want to tell you just end with a little story about Jordi. When I decided to go down the rabbit hole and go from playing with my children to actually doing this right, I realized pretty quickly that we would need to start a company to make, it was one thing to put the files out there, but we needed to make it easier for people and make the boards for them. So we needed to start a company. And I set up this community, DIY Drones, which is based on a social network, and there's about 20,000 members. And one of the guys there was doing this amazing stuff. He was flying a remote control helicopter with a Wii controller. And it was just seemed incredibly creative. And so we got talking, and we ended up doing a blimp together, an autonomous blimp. And then I said, you know what, would you like to start this company with me? He said, sure. I said, well, maybe, at this point, you should tell me a little something about yourself. Jordi Munoz was a 19-year-old high school graduate living in Tijuana, Mexico. Never been to college, still hasn't been to college. Today, he is the CEO of a multi-million-dollar aerial robotics company that's competing with some of the biggest aerospace companies in the world. He's now 24. He is running an extremely high-tech manufacturing operation. He gave himself a Google PhD. Everything he needed to know, he learned online. He is the answer to Bill Joy's paradox. The smartest people in the world do now work for me, not because they're necessarily employees in my company, but because we set up a community that gave them a place to contribute. We don't look for them, they find us. They find us because they want to do this, and we give them a place to do it. We have more than 100 developers. Some of them are Apple engineers, there's Google engineers. Some of the biggest companies in the world, including hardware companies, are contributing to this, but they don't know it. It's their rock star engineers at night. By day, they're designing chips for Intel. By night, they're designing autopilots for us for free. Why are they doing it? Because this is their passion. And volunteers are better than conscripts. And people driven by their love are better than people driven by command and control instructions. That's what using the web's innovation model has allowed us to do. And that's how the editor-in-chief of Wired Magazine ended up starting an aerial robotics company with a 19-year-old high school dropout from Tijuana. So that was our first workshop. This is just a tiny glimpse of our latest one. This is just one of our many pick-and-place machines. In our new factory, we've just moved to a 10,000 square area. This is what we're doing now. In just 3.5 years since I was playing with Lego in my children, all because the tools were there, easy to use, the technology had been democratized. The word desktop changed everything. Desktop meant that we could not only afford it, but we could use it, and that more to the point, it didn't matter who we were. Anybody has a desktop. Anybody's ideas are now worth making because the technology has scaled down to their level. So my slogan on this is, atoms are the new bits. And the point is, you ain't seen nothing yet. The web revolution, as tremendous as it's been, was the world of bits. And the world of atoms is 10 times larger. Thank you very much.